Okay, so there was a couple of things Alan talked about in this lecture. One was polynomials. Now, polynomial is just something that looks like this. Where you've got x cubed plus something times x squared plus something times x plus something times 1. It could be an x to the power 4. X to the power 5 could be your highest, which is its degree. But let's see if we want, is this a factor of this? Now, there's two ways you can do it. You can use division. So x plus 1, does it divide into this x cubed plus 3x squared plus 3x plus 1? Okay, so the first thing, we just look at this lead term really and say, if we wanted to times x by something to get to x cubed, that would be x squared. And that's really all it is. X squared times this is going to be x cubed, which is exactly what we want, plus x squared. And then, we can just subtract these two things. So 3x squared minus x squared is 2x squared plus 3x, and we bring down the next power. So the first thing we say is, how many times does this go into this? So how many times does x go into 2x squared? That would be plus 2x. And then we multiply back. 2x times this is 2x times x is 2x squared. 2x times 1 is plus 2x. And then it's a case of, then we minus these two things. This always cancels out, that's the whole point. Then this is 3x minus 2x is just x plus 1. How many times does x go into x? It's plus 1. How many times does x plus 1 go into x plus 1? It's just 1. So what we've got is, in the final situation, and this is how Alan wrote it, that px equaled qx multiplied by, I don't want to use rx, but let's just say sx here. So px equaled x plus 1 times x squared plus 2x plus 1. Okay, so that was the first nice simple division. The other way we could have done it was we could have just basically said, we now know that this x cubed, these two things are the same, x cubed plus 3x squared plus 3x plus 1, that this factors to this. So instead of doing all that, we could have said, well, if this is minus 1, if we put x equals minus 1 into this or into this, same thing. If we put x equals minus 1, this becomes minus 1 plus 1, and this is going to give 0. 0 times anything equals 0. So instead of doing all the long division, we could have said, if we want to find out whether x plus 1 is a factor, we just find the value of p minus 1. Or we put minus 1 into the equation and see what happens. So let's look at another one. And we'll do it both ways again. Is x plus 3 a factor of this? So we set up that division. X plus 3, does it go into x cubed minus 2x squared plus 4x minus 7? So really what we're doing is, if we had something like 11 into, 3,672, we would say, how many times does 11 go into 36? And we would say 3 times. That's exactly what we're doing here. How many times does x go into this? X squared times. And then we multiply it back. X cubed plus 3x squared. Over here we go, 3 times 11 is 33. And so our remainder is 3, and then we bring down the next term. It's exactly what we do here. We minus these two things. Now, you've got to be a bit careful. Minus 2 x cubed minus x cubed is 0, exactly what we want. Here we've got minus 2x squared minus 3x squared, which is x squared plus 4. And then we bring down the 4x, just like we brought down the 7 over here. So minus 2x squared minus 3x is minus 2x squared plus 3x. Then we do the same. How many times does x go into x squared? Plus x. Or x times x gives us the x squared plus 3x. What was our next step? Over here it would be exactly the same. 11 into 37 goes 3, and you multiply that. 33, and then you minus to get 4. Over here, so what are we up to? We're up to minusing. X squared minus x squared is 0, exactly what we want. 4x minus 3x is x, and then we bring down the next thing. Does x plus 3 go straight into this? It doesn't go straight in, so it's plus 1. So 1 times this is going to be x plus 3, and we're going to minus again. X minus x gives us 0. Minus 7 minus 3 is minus 10. So we have a remainder in this case. This is the remainder theorem, basically. So px equals this whole thing, x cubed minus 2x squared plus 4x minus 7. But we've factorised it, or split it up. We didn't really factorise it because it wasn't perfect, into this. So what we could have done instead of answering this question, is x plus 3 a factor, we could have just gone straight away, let's see whether x plus 3 is a factor. What would x to the minus 3 equal? Well, minus 3, if you put this in, is minus 3 plus 3 times 3 minus 3 squared plus 3, minus 3 plus 1 minus 10. It doesn't really matter what this bracket is because this is 0. And 0 times anything is going to give us 0. So we're going to get 0 minus 10. That is the factor theorem. Minus 10. The factor theorem basically states is when x plus 3 is divided into this, the remainder is minus 10, and p of minus 3 is minus 10. Those two things are always the same. Thanks, bye.